Example 3, we want to verify now that a repeating decimal could be written as a rational number. Integer over integer. Alright, the problem with a repeating decimal is it has infinity numbers in it. So if you imagine doing it the way we just did it. Okay, don't write this down because this is wrong. But if I were to write this down, 0.01623 repeating. How many decimal places is that? It's infinity, right? Because it's 2, 3, 2, 3, 2, 3, 2, 3. So I got to write infinity zeros down here, right?
No.
Not going to do it. All right, so not going to work. All right, so the technique we just did is not going to work because a repeating decimal has infinity decimal places. I can't put infinity zeros. I'll get writer's cramp after about the 10th. And then after that, I'll just be miserable. All right. I think right around the billionth decimal place, my arm starts to fall off, probably. I'm guessing it. Yeah. It would not be a good thing. So we got to come up with a way to get rid of the infinity-ness of this. All right, so here's how it works. Number 1, pretend that you've written something on the line above what we're going to write. So pretend that there's something here, even though there isn't. Then I'm going to write x equals on the line below, and I'm going to leave a little bit of space, and I'm going to write 0.01623 repeating. Start there. Again, there's a blank space above it because, and so on a piece of notebook paper, leave the top line blank, write this on the next line down. And I might even put a 1 in front of the x just for effect. What I've done here is I've established that x equals the number that we care about. So this number here is now referred to as x. How many digits repeat?
2.
2. All right, that's important. The number of digits that repeat is important. You want to take 10 to that power. So what's 10 to the second power look like? 100. Okay, what I'm going to do is I'm going to multiply both sides of this by 100. And that's what I'm going to put on the line above, my blank line. So if I multiply 1x times 100, what do I get? 100x. And if I multiply 0.01623 repeating times 100, how far does the decimal point move?
To the 1.
Moves right between the 1 and the 6, right? So I'm going to get 1.623 repeating. Don't put the repeating bar. I can erase easier than you guys. Right? Now, the reason I want to do this is I want to create another number with the same repeating sequence. That's the key. This number is not the same as this number, right? But they have the same repeating sequence. I also want to put the same repeating sequence in the same location. So right now, the 2, 3 repeating is over the 16. That's no good. So what I want to do is I want to put an extra 2, 3 here. So 2, 3 repeating go there also, right? If I put the repeating bar there, it means the exact same thing as if I put the repeating bar there, right? But now, notice position 1, 6, 0, 2, 2, 1, 3, 3, 6, and then 4 and 5 are both 2, 3 repeating. So this is 2, 3, 2, 3, 2, 3 all the way to infinity. So is this one 2, 3, 2, 3, 2, 3 all the way to infinity. All right? So again, when you do the times whatever power of 10 you do, put one of the repeating sequences down, and then the next one lines up with the repeating sequence in the first one. Then you put one of these cool little bars. And what I'm going to do is I'm going to subtract the bottom from the top.
Do you want us to have that fraction bar with the 2, 3 on the top one now?
I want the repeating bar over that one, yes, please. All right, so I'm going to subtract this blue one. So I'm going to put minus 1x and minus 0.01623 repeating. And what happens on the left-hand side is pretty basic. What's 100x minus 1x? 99x. Okay, on this side, the 2's cancel the 2's, the 3's cancel the 3's all the way to infinity. This is just 2, 3, 2, 3. So just imagine 2, 3, 2, 3, 2, 3, 2, 3. And this is 2, 3, 2, 3. It's hard to write. 2, 3, 2, 3. Right? 2 cancels 2, 3 cancels 3. 2 cancels 2, 3 cancels 3. All the way to infinity, right? So the effect all this has that we did, since we got these two repeating things in the same location, we're subtracting, is, and even though there's infinity of them, it's sufficient to just do that. The 2's cancel the 2's, the 3's cancel the 3's. Those are gone. And just like that, the infinity goes away from the problem, and we're left with finite. We're left with simple. So 1.623 minus 0.016, borrow 1. 13 minus 6 is 7, 1 minus 1 is 0, 6 minus 0 is 6, and 1 minus 0 is 1. So 99x equals 1.607. So if I divide both sides by 99, I'm at the same point I was in the last problems, right? I've got a decimal on top over a whole number. This time instead of being 1, it's 99. It doesn't matter what the whole number is. This is not a good fraction, right? How many decimal places in the top? 3, so I need 0.000 on the bottom. I throw the decimals out, I end up with 1,607 on top over 99,000 on the bottom. Now, here's the one last thing. We want lowest terms. We want to reduce the fraction. Always go lowest terms. Okay, before it was just 2 and 5 we had to check, right? Consider 99. 99 is 9 times 11. 9 is 3 times 3. Right? And then as far as thousands concerned, that's 2, 2, 2, and 5, 5, 5, right? 3 zeros, so 3 2s, 3 5s. Thousands 10 to the third power, so 2 times 5, 3 times, 2 times 5, 2 times 5, 2 times 5. So this right here is the factored form of the denominator. If I'm trying to reduce the lowest terms, all I got to do is check those factors. Does 2, 5, 3, or 11 go into 1607? So let's start with 2. Does 2 go into it? Does 5 go into it? Those are easy, right? Alright, 11 is not quite as easy. Okay. There is a divisibility rule for 11 if you want to see it. The easier way to do it is this. 1607 divided by 11. Decimal doesn't work. Alright. The divisibility rule for 11 works like this. You add every other digit. Subtract the sums. If that divides by 11, the whole thing does. 13 minus 1 makes 12. 12 doesn't divide by 11. Right? If that was 1606, right? 12 minus 1 is 11. That divides by 11, right? Watch this. 1606 divided by 11 divides evenly.
Whoa.
All right? So again, add up every other number, subtract the 2. If that divides by 11, the whole thing does. But again, if you just want to do a quick check on your calculator, this divided by 11 doesn't work. So 11's out. The divisibility rule for 3, add them up, and if it divides by 3, the whole thing does. 7 and 7 is 14, doesn't divide by 3, so the whole thing doesn't. Again, if you weren't sure, 1607 divided by 3 doesn't divide. So that is reduced lowest terms, that's the answer. Just like the last problems, we have the ability to check. 1607 divided by 99,000 should equal 0.01623 repeating, 0.01623232232. Keep in mind with the repeating thing, if it's a big enough number to round up, it might not look the right way, but if you just see the repeating stuff, it should be enough to convince you. And notice that this says x equals this fraction, x equaled our decimal, x equals both the fraction and the decimal. That verifies the fraction and the decimal are the same thing. 1607 is an integer, 99,000 is an integer, therefore that is a rational number.